Being able to read XML information is all well and good, but for the language to be truly useful to us, our Java programs probably need to be able to write out XML information as well. The program in front of us is a bare bones model of a program that both reads from and writes to the same XML file. Its main method is extremely simple. It takes a file and then it reads XML from that file, storing it in an XML document tree object. Then this program calls writeXML document to write the XML back out to the same file. Currently, the method that reads in the XML has been implemented for us. However, the method to write out the XML is not yet complete. Let's see what needs to happen for us to write XML information to a document. Because of the way an XML document is stored, we need to convert it to a different format before it's really feasible for us to print it out to a file in the same formatting that we got the original XML. To do this, we're going to make use of an XML specific class called the transformer. As with a number of the classes we deal with when dealing with XML in the document model, transformers are best created using a factory. In this case, that factory is called the transformer factory, and like many factories, it exposes the new instance method, allowing us to create one when we need it. To get our new transformer, which will allow us to convert our document object into something streamable that we can send to a file, we're simply going to call our transformers factory's new transformer method. Now, before our transformer can transform our XML document into something else, it's going to need to know what we would like it to convert our XML document's information to. This class is the streamResult class. It's the target for the information stored within our current document. The stream is a raw binary information pump that can be sent to any number of targets. In this case, our target is going to be the destination file provided to this function. Our transformer, though, is not automatically linked with our XML document, and it expects us to reference our XML document in a unique manner. This is as a DOM source object. Notice that our source object here is being paired with a result object. The transformer, when we provide it both of these objects, will know to convert one to the other. Now, to create our document model source object, we simply need to pass in our XML document. Finally, when all that setup is complete, we can execute the functional piece of code. Let's grab our transformer and ask it to transform our source, our document model object, to a streamable result targeted at our destination file. When we run this program, we'll get some XML in our file, but you'll have to trust me when I say this, this is the same XML we had before, which is to be expected, seeing as we read in the XML and then printed it right back out. To really test if our program is working, we're going to need to make some changes to our document object within the Java code and then see if we can print those changes out to this file. Let's change the names of the car's owners. Let's transfer the deals to all of these cars to an owner called Mike. The power of the XML input-output system is that in between loading and writing our XML document, we can freely modify this document object stored in memory, and the changes we make to the object in Java memory will then be written out to our permanent XML file. So, let's begin making some changes. We're going to use getElementsByTagName to get all of the owner elements in our XML document. This will return a node list, and we'll call it owners. To convert the names of all of these owners to Mike, we're going to have to loop through this list. As a refresher, we can get the number of items in the list by calling owners, the node list, getLength function. And to access the item that we're currently iterating through, we'll use the owner's item function and pass in our iterating variable I to get the item at that index. Let's store this value in a variable so that we can use it easily. And once again, we'll just assume that our XML is well formatted and inform Java that we are in fact dealing with a fully fledged XML element at this point. XML elements expose a number of methods that allow us to modify them. One of these elements is the setAttribute element, or method, and that's what we'll be using here. SetAttribute takes two strings as input. First, it wants to know what attribute we'd like to modify. We're going to be modifying the name attribute. It's the only attribute available to us here. And we're going to assign its value to Mike. When we run our program now and check our XML file, we'll see that Mike is now the owner of all these cars. It might make sense now to combine these two XML elements so that Mike is only a single owner, not split into two. That's a little bit out of the scope for this tutorial video, but it's an interesting question and one I encourage you to reflect on and maybe take a shot at right now.